Hi there. So this is the first video of a new series that we're going to have in our 90-day countdown to A-level. So we're going to start off where it all began. This is based on the first question that was ever asked on the A-level paper. So today we're going to look at how you can much better use brackets to avoid some mistakes. So we've got a small angle approximation question. So there are some clues. When theta is small, measured in radians, use the small angle approximations. Okay, so small angle approximations are as follows. So actually sine and tan are your really easy ones, and cos is where everybody goes wrong. So what's not obvious with these small angle approximations is if you have something like cos of 2 theta, this bit here, that is the same as this theta here. So we need to be very careful when we substitute it in. So this will actually be the same as 1. So I'm going to use my brackets. I'm going to do it like this because I'm not going to forget to fill in this space here. And I'm going to write 2 theta in there. So for our first one here then, what do we get when we do our numerator? We're going to get 1 minus 2 theta all squared. Put the brackets in there. That's the bit that everybody does wrong. Minus 5 theta cubed. Okay. And if we do some cleaning up, we're going to get 1 minus 4 theta squared. I'm showing every step here. This is a common show that question, so it's a good habit to get into. Okay. So I've got that as follows. Minus 5 theta cubed is my numerator. My denominator then, let's do my denominator. So theta is just theta, tan theta, that's quite a nice one. So here we go, it's going to be as follows. If we clean up this part here, when you have one thing in the denominator, you can do the following. So it will be 1 over theta squared minus, what would that be? 2 theta squared over theta would just be a 2, okay? And it would be a minus 5 theta, okay? So that's how you would do that kind of question. So in particular, we're really trying to be careful about our brackets here. Here's one more example, a trickier one for us to have a go at. So when theta is small, measured in radians, small angle approximations, these are all clues for what we need to do. We're going to be using our results from the formula booklet as follows. So let's jump into it. I'm going to start working with the numerator. So 1 plus, let's just use our approximations before we do anything else. So sine 5 theta is approximately 5 theta. Okay, over here, so let's put some brackets in. What's the rule here? So the rule is that whatever goes in this position here goes in this position here. So this is going to be 1 minus 3 theta squared over 2. Okay. And again, that's all going to be over, well, theta times theta. How about we just jump in with theta squared? Okay. Let's do some more work on this numerator here. So I'm going to have 1 plus 25 theta squared minus 1. What else is going on? Minus, this is a double negative. So this is going to be equivalent to adding these ones together. And what would we then have? We are going to have 9 theta squared over 2. Let's do some work from here. So let's just carry on with this for a bit. 25, well, if I want to put that over 2, I would have to multiply the numerator as well. So let's do that nice and neatly. So that's going to be 50 theta squared over 2 plus 9 theta squared over 2, which is 59 theta squared over 2 for my numerator. I might just write my numerator here so I can show what I've been doing. When I when I have, what's this, 59 theta squared over 2, still being divided by theta squared, scanning back over my work, checking for any mistakes, you may wish to instead write this slightly differently. If I am dividing by theta squared, then that's kind of the same as multiplying by the reciprocal. And now I'm pretty much there. So my final answer is that this is approximately the value of 59 over 2.